Okay. Hello everyone. Good morning. Today we are going to see, is fast API really fast? I think it's the buzzword we have heard from the last 5 to 6 years. Fast API is coming with a faster speed for developing different backend applications. So I'm Princekumar Dobariya. I'm software engineer at BBD Software. I basically work with Django, Fast API, and recently I'm also exploring the generative AI space with Fast API and Django both. So let's talk about frameworks. Has anyone tried Fast API in production? Raise the hands. Yeah? All Fast API people are here. And has anyone tried to benchmark the Fast API or like any kind of framework they are using? Yeah, it's good to see someone has tried. So if you have tried, it's good. If you have not, we're going to see some of the benchmarking results from the open source repositories, as well as people done some of the benchmarkings in different categories, and some of the benchmarks which I think should be there. So your whole application performance is just not equal to your framework which you are choosing. So if you are choosing Fast API, it just doesn't mean like it will directly suit for your application use case. There might be different use cases, such as if you are using IO-bound API calls, then it would be good fit. But if you are directly using the CPU-bound calls and you are creating the async APIs, it will just does not suit. So there are different categories where Fast API leads and Fast API lacks. So if you do not know Fast API, it's backend API creation framework created by Sebastian Ramirez back in 2019, and it got so much popularity. These days, I think if you see any generative AI applications, people are using the Fast API for its use, and it's just so fast to develop all of the backend applications. So how Fast API actually created? The first is Starlet. So Starlet is basically micro framework created back in the days, and Sebastian Ramirez took the Starlet. Then he uses the Pydantic and the main thing, which is UVCon and UVLoop. They are giving this performance to the Fast API to build the async native applications. And the moment you start writing Fast API code, or even you just start writing any API into the Fast API, the next moment when you run your Fast API application, you will just directly get the documentation. And these are just request flow will just work. Your client will send the request, it will go to the UVCon server, and Starlet will do the routing, and Pydantic will take care of your serialization and the validations. So when I actually saw the Fast API, I got to know about this word, or we can say the statement, on par with Node.js and Go. If you are a Node.js developer, don't kill me. I was not the one who said this statement. And I got curious, and I went to the GitHub thread on the Fast API GitHub repository, and some people were also not happy with that statement. So someone just got offended, and he just started one GitHub thread. It's really interesting GitHub thread. You can just directly check it out. So what he tried, he actually tried the benchmarking the Fast API with just hello world. But is it the right way to benchmark your API or backend applications? So actually, when this statement came, from which was the source from this statement came. So back in the early days, Tech Empower did some of the benchmarkings on different frameworks. So if you are using any kind of web frameworks, you can definitely go to the Tech Empower's benchmarking website, and you can see where your application is leading and lagging, and how much throughput your backend frameworks performance is there. So how they actually did this benchmarking. So there were some of the categories they chose. First is JSON serialization, basic, hello world. You put into Python dictionary, and your API will just directly send it to as a response. Second is single query. You have a database, and you are just making a get query. A third is multiple queries, fortunes, data updates, and plain text. We are going to see in the detail how the categories looks like. So when they did this kind of benchmarking, so what they actually did they created a whole repository, and they ran this whole repository into Docker containers into AWS, Microsoft Azure, some of their virtual machines. So how which was like a kind of their setup was for the framework benchmarking. So they have backend APIs created into different folders. They have dockerized it, and they are using it actually into different kind of combinations, like with ORM, without ORM. So you can actually see where it is lagging and where it is leading. And they have also created combinations with different kind of database such as Postgres, MySQL, MariaDB, MongoDB. So if you go to Tech Empower's benchmarking, you will definitely see all of the combinations there. And which tool they have actually used? They use the WRK tool, which is, I think, these days most people are using to benchmark or trying to create a load on to their backend applications. So let's see the first category which they tried. It's just simple JSON serialization. You have a message in a Python dictionary, and it will just get serialized into JSON. Second is single query. It's kind of you have a data into your database, and you are just asking, give me the one first product of with this ID 1. The third is multiple queries. So in this multiple queries, I think in our backend applications, when you are building an API or any business logic, you will see you are just not only making one query. You have a backend logic, you have a business logics. Sometimes your applications are calling different services. So they just try to mimic it by just running one for loop with like random number of range, and they will just pass all of the response as a get. And the fourth category is fortune. It's basically you are just rendering your HTML template. So you have a list of product and you want to render it into HTML. So get the product from the database and serialize it, converting into template response and give it to the user. The fifth is data updates. So here also, what they did is they just ran a loop. You can choose how many data updates you want to perform in your backend applications. So you will just, they have just added the queries like 500 data updates or 100 data updates. The sixth is plain text. I think we have seen this same plain text into that GitHub thread. The person who got offended tried this plain text kind of a benchmarking. So today, which frameworks we are going to focus? First is FastAPI, obviously. Second is Flask. Third, Django. And Go, Go-based framework, which is Gin, and Express.js. So before going to the benchmarking results and all of the inner working, let's see which tool they have used. So if you want to benchmark your backend application, you can just use this tool, WRK. It's basically a HTTP benchmarking tool. You can even include your post request, like you can write a Lua scripts, and you can add your body to your API endpoints, and you can just run it. So how actually WRK is working? So this is a small command which you can try even on your own as well. So it's just WRK-T2. Means wherever you are using WRK, it will use 2 threads from your CPU core, and it will use concurrency as a 6. Means you are replicating kind of your production kind of a use case where you have 6 clients continuously hitting your backend applications, and this is how WRK is doing some of the benchmarking, and it will give you result like this. So it will give you which URL you have used. It will give you the latency, request per second, and it will also give you the main thing, which is how many requests your backend application was actually able to handle during this time duration. So let's see the overall ranks for the 2025 benchmarking from the Tech Empower. So let's see the first, which is JSON serialization. So as we have seen that statement, FastAPI on par with Go and Node.js. We can't see FastAPI is leading above the Gin, which is a Go-based framework. Here, one thing to note is the numericals which are there. For example, 498,192 is basically how many requests this Gin application was able to handle within a duration of time when Tech Empower did the benchmarking. So in the JSON serialization, Gin is winning, FastAPI comes second, third, Express. So we can see in this category, FastAPI is actually going like little bit above the Express.js. But Django is lagging behind, and Flask is also on the last. And the multiple queries, we can see the difference. Gin and Express, they are just switching their places. And FastAPI is still on the second. So we can see like it's coming into the ballpark. So Gin is a Go-based framework, and still FastAPI is able to go beyond its performance. And the third is data updates. We can see the similar results, but here we can see the Flask is actually leading then Gene as well. In the plain text, we can see again Gene is winning, FastAPI comes to the third. In the fortunes, we can see Express is again leading, Gene is second, FastAPI third. In the single query, we can again see Gene is winning, Express comes second, and FastAPI third. So what I got to know is when I saw their GitHub repository, this should be like whenever you are creating actually any backend API of let's say you want to create a product into your application. So how the the workflow should go. First, the client will send the request. It will go to the API router. There will be a JSON parser, which basically converts JSON into your framework's language and kind of a data structure conversion. And there will be your endpoint logic, and you will connect to the database, and so on. All of the operations comes. But when I saw the Tech Empower's benchmarking repository, I saw one thing which was not there, which was this JSON parser. So if you have seen like in the data updates, this thing was not there. But in real time, we definitely need JSON parsing whenever even you are doing a post or a put kind of API calls. So what they were doing, they've just created all of the APIs as a get, no delete, no post, no put, nothing. Just all of the backend applications were, all of the framework were using directly just get request, and all of the logic they have used. So what I thought, let's try to do the benchmarking by myself. So what I did, I pick up some of the categories from the Tech Empower, and I also tried to add some of the categories. So plain text, JSON serialization, post, put, get list, get one product, get fortune, similar to the Tech Empower benchmarking, and another which is additional, which is delector product. And what I did differently was I used FastAPI with different kind of combinations. I created similar APIs with FastAPI, but their APIs were into async mode. All of the APIs were async. I also tried copy all of the APIs and created into all of the APIs were into sync. And I also tried to combine what is the performance with the UVCon as a web server, what is the performance with the Gunicon as a web server. And I tried Flask with Gunicon and Django with Gunicon, and I think Express comes with its native web server, and Gene is also coming with Go's backend server. So what I did for the post API, it's basically simple. You are just creating a product. There is a model. Whenever you hit the API request, it will do the passing, and it will just directly create the product into database, and it will send you back. For the put, I did the similar thing. I added the model, and let's say if you want to change the name, you will add into your body, and it will do the database validation, and it will update on the database, and it will just give you the latest updated product. And for the delete, it's simple, just delete from your database. So how I did it, actually, I created this open source repository under this my GitHub account. You can definitely check it out. It's open source, and if you wish, you can also contribute to this repository. So what was my approach actually for this each framework benchmarking? So I similarly use WRK and Lua scripts, but I combined with a Python script which will do the benchmarking in one go for all of the frameworks, and it will give you a CSV file to see all of the results. And I tried different web servers, and mostly I created the CRUD APIs because that we do mostly. And I tried mostly all of the backend frameworks with ORM supported, because these days most of the people are preferring ORM over just SQL queries. And I try to use Postgres database. So for the ORM, I use the SQL Alchemy with the FastAPI, with the Flask, same, and Django just come with its own ORM. And Express, I tried the Prisma, and Gin, I use the GOM ORM. So I also tried what I tried to make clean is like when you are running even your Gunicon server, if you do not say like this many workers, it will just spin up the 2 worker. So I tried to maintain like 1 worker per whenever I'm running any application, Flask, Django, or FastAPI. So for the web servers, I use the Gunicon, UVCon, Node.js as a default, and Jin's default web server in Go. So before going to the results and some of the benchmarking, let's see one word, which is WSGI, Web Server Gateway Interface. So whenever you are using Gunicon or WSGI based frameworks such as Django or Flask, So basically, it will process one request at a time because it's not natively async. But if you try ASGI based web frameworks such as FastAPI, what it will do, it will keep the event loop and it will handle all of the request, and it will execute all of your backend application logics into an event loop. So this how you will get the better throughput. So when I actually tried this benchmarking, which tools I have used? So first is obviously WRK. I used 2 threads, concurrency was 5, and duration was 60 for each benchmarking categories. So I actually tried to run this whole repository on AWS EC2 instance, 4V CPU, and 8 gigabyte of RAM. I used the Docker containers for the ease, and everything was in Python script. So how I did the table, of what kind of approach I used for the database. I just created one product table, and I added some of the fields to just mimic kind of a real world use case scenario. And in the script, I also added some of the key functions where for each category you are not over exaggerating your database with like multiple rows. So let's see. Any guesses who will be the winner in the benchmarkings? Fast API, Jin, Go. Let's see. So here, higher is the better. Total request sent in the 60 second. So in the get, Jin winning. And Fast API with Gunicon and async APIs, it's on the second. And third comes Gunicon with sync APIs. And Express on the fourth. We can see the combination with Fast API, it's actually improving the performance. You can see 1,49,000 with sync, and 3,79,000 with async. And in the plain text, again, Jin winning, Fast API second, third Fast API, fourth Express. Fortunes, you can see Express is leading in fortune, template rendering, second comes Jin's, third comes Fast API. In the second single query category, Jin again leading, Fast API with Gunicon and async combination, it's on the second. And we can see Flask is even beating the Express in this kind of a category. And for the list product, it's basically you are getting all of the kind of 1,000 products from your database. So at that time, Jin is leading, Express second, third Flask, and fourth Gunicon with async, Fast API. With the data updates, again Jin is leading, Fast API third. In the delete category, Jin is leading, Fast API second. In the post category, Jin is leading, Express second, and Fast API with Gunicon and async compatibilities comes the second. If you want to see the more detailed results, I've already uploaded this CSV benchmarking results into my repository. You can even see what was the latency for the each categories and each frameworks. If you want to run it on your local, you can definitely run it. You just need a Docker and Python in your local laptop, and you can just try to run those steps. So final verdict, on par with Node.js and Go-based framework? I don't think so. But we can say its performance is coming into the ballpark where Node.js based framework and Go-based frameworks are giving the performance. So Python is coming there, but not beating in all categories, not beating all of the Go-based frameworks. It's only beating the Jin, but if you compare with the Fiber, if you see the Tech Empower's benchmarking results on results, it cannot beat the Fiber. So basically, in the underline, if you are using Go-based any framework, it's basically Go code. So it will definitely run fast because it's compile time environment. But if you see the Python, its interpreter, it is slow. It's not that fast. But there are some of the things with Fast API using to make it fast. Same applies to the Node.js and Python. It's just they have different languages. So when we are comparing the frameworks, we should take care of this kind of a use case where there are different languages. And even we have seen in the benchmarking results, like if you just switch your web server, let's say if you just use the UVCon web server, you will not get that much throughput with Fast API. But if you use the Gunicon as a master server and UVCon as a child processes, it will definitely give you better results because Gunicon is it's really good at handling this kind of load. when you are running into the production. And if you even see the Python's some of the frameworks with Socketify web server, its speed is sometimes like going above the ballpark where Gene and Node based frameworks are giving the performance. So this is the cool thing which making fast API really fast, which is event loops. So when you run the fast API just with pip install fast API, it's basically using the async IO. But the moment you just use UVCon standard, or you will just say pip install UV loop, at that time you will just get the benefits of UV loop. So these are the basically benchmarking results from the UV loop. It's kind of a alternative of your async IO event loop, but it's giving like really good performance than the native async IO. So if you can see on the screen, like UV loops performance are in some of the categories, it's even going beyond the Golang base. It's like coming neck to neck. So because of the UV loop, Fast API is getting this kind of throughput and performance. So is it fast? I think it's always depends what kind of use case you have, which kind of API endpoints you are using. If you are using sync API endpoints for the async compatibility, it will just not suit. You definitely need to build your async API endpoints. Then you will get the better performance. So for the fast API, its raw throughput basically means like from the benchmarking, it's just not equal to the real world backend applications, because we have seen like if you just switch the server, your performance will boost. And for the each frameworks, you can try different kind of combinations for the server as well as some of the serialization libraries as well. So when you're choosing a framework, you also need to take care of one thing, which is development speed. Let's say you want to build one agentic AI applications in the 3 weeks. You should not go with the Golang, because it will take some more time. But if you go with the fast API or any Python based framework, it will give you a boost. Even let's say if you want a Django like kind of an admin panel into your applications, you do not want to build the front end, you can just go with the Django, and your backend applications with kind of a built-in admin panel will just be there. And another thing, which is ecosystems and libraries. So with the fast API, it comes with so many integrations and libraries. And also one more thing, which is team familiarity. Let's say you have a Python team, and you want to build your application. You want so much concurrency and performance. You definitely need to hire a Golang developer, or you need to compromise with the time, because your team will learn the Python, some of the optimization techniques with the Python fast API or any framework you are using. So it also depends on your team familiarity. And async versus sync. So let's say you are running a sync, what can I say, CPU bound use case with an async APIs. It will just block your whole event loop, and it will give you like very poor performance. But let's say if you are building an agentic AI application, you should definitely go with the async APIs, because it will handle all of the things behind the scenes into the event loop. So you will have a better throughput, and your server will be able to put all of the requests into the event loop, and it can use all of the capabilities from the event loop, and you will get a better performance and deployment complexity as well. So with the fast API, there are different combinations you can try, async UVCon. But the main thing is serialization with Pydantic. So when you are serializing, when you are adding any body to the fast API, basically Pydantic comes in the picture, and it is using the Rust language performance into the fast API, because it's built upon the Rust, and your serialization will go into the Rust, and this is why you are getting the better performance. Another, which is async support. So when the fast API came, it was just not for the sync. Basically, it's hype for which was for the async APIs and the automatic documentation. So if you are using Django or even Flask, if you want the moment you write the API, you need to either install some of the libraries, or you need to write some of the JSON schema to create documentation for API. But in the case of fast API, you just write your your API, and fast API will take care of all the documentation. You will just run the fast API, and you will just get directly the documentation in your browser. You do not need to write anything extra. And if you are building generative applications, fast API is like a first choice for the generative application. But with Django, so we have seen in the benchmarking, like Django was lagging behind, it was just not in the picture. But it doesn't mean the Django is not taking a stand. If we see in the back end of days, Instagram was built upon the Django. So what Django is giving is power of batteries. All of the middlewares are there, all of the security libraries are there. Even you can directly use your settings. And the cool thing which I love mostly about Django is its ORM. So you can basically, whenever you have a tight deadline, you want to create a like quick MVP, you can just go ahead with the Django. And with the Flask, it's minimalistic, but you have to bring your batteries, like third-party libraries, some of the integration. Let's say if you want a documentation, you need to install a third-party library. It's kind of a micro framework, but it's still useful. We have seen in the benchmarking, like Flask was even beating FastAPI in one of the or two of the categories. With the Node.js, I think it's basically async first event loop. It's basically faster than FastAPI in many of the categories. And it has a huge NPM ecosystem. I think if you want to use the Prisma, you will just say npm install Prisma, and like so many. Its ecosystem is really great. And if you have a kind of a full stack application where your devs are using all of the JavaScript, let's say Next.js, React.js, Vue.js, you can just directly go with the Express.js framework. With the gym, I think it's already faster. We have seen in the benchmarkings. So basically, it gets its speed from the Go routines and its schedulers, and it's basically compile time. So it will definitely be faster, and it's basically used in many of the high concurrency and high performance needed applications. So when to choose what? So when you're choosing a backend framework, you will definitely see the raw performance. But another way, you also need to see what is your use case. Is it recently generative AI based application use case, or you need to just create your backend applications for your infra? And you also need to see the ecosystem it is providing, because if you are just trying the new framework directly, you might lose the maintenance support, because you need to see like how well maintained your backend framework, and some of the third-party libraries are there also. And the fourth thing, which is your team expertise, obviously. If you are a really great team in Python, so if you just building some of the generative AI application, you can just directly go with the FastAPI. So when to choose worst? First, your use case. Choose your use case, then see the performance, either from the Tech Empower's benchmarking. You will definitely get an idea where your combination, kind of a database you are using. So let's say you are using a MySQL database, and you are seeing your APIs are not that good. But if you just switch to the PostgreSQL database, you will see the performance boost, because Postgres is faster than MySQL. So there are also different kind of combination you need to see which kind of database you are using, either using NoSQL or SQL. Even on the Tech Empower's benchmarking, there are also benchmarking for the Redis cache usage. So you can also see the how any backend framework is performing with the Redis cache. And your team expertise, as same as, and the deadline. I think if you have tight deadline, you can just go with the Python. It's easy, and you can just build the things very easily. And community support and ecosystem. So this isn't just an idea of mine. So if you need a high concurrency and like you have very async bio kind of a use case, you can just go with a FastAPI or Gin, which is like Go-based framework. But if you need full ecosystem, batteries included, and you want just faster development, you do not want to build, you do not have a front-end developer, and you just want to build the backend, and you also need a kind of a admin panel for yourself. You can just directly go with the Django. So Django is used by many big companies, Instagram, Pinterest, Rippling. So it's really good framework. And with the simplicity and maturity, it's like very simple. You have very minimalistic use case. You can just always go with the Flask. And with the Flask, I think it's very lightweight. If you are very concerned about your infra cost, or your pods are taking so much memory, I think Flask will be like a good fit. So Netflix is actually using it for the internal tooling. And if you are like full JS team, your full stack is in JS, just go with the Express, even with the generative application. But with the generative application, you also need to take care whether the third party library, whether it's agentic library or some of the LLMs SDKs, they should also support the JavaScript. Otherwise, you can just go with the fast API. And if you just want the high performance with your infra APIs, you can just go with the Gin. And generative AI backends, my first priority would be fast API because it's backed by the async event loop. And it's I was also shocked when I read this thing. OpenAI is actually using the fast API for their backend services. The final choice is like there is no silver bullet. Like you should just choose this. Pick the framework that fits your use case and team, not just the benchmarking charts. Thank you. These are some of the links for my benchmarking repos and a link for the Tech Empowers benchmarking and WRK tool if you want to try to benchmarking into your local and that blog post for the UV loops benchmarking. If you want to go into the deeper, you can definitely look at the UV loop. Thank you so much. I hope I was not that fast.